Alright guys, this is my second attempt at making this video today. I hope it goes better. I'm just having one of those days, I guess, but this is part 2 of topic 3. I wanted to combine this with binomial probability, but that video just got too long, so I'm going to quickly go through measures of center and variation or standard deviation and box plots. This should hopefully all be review from many years of doing this stuff. Measures of central tendency are simply ways of measuring the center or middle of the data or summarizing the data. So when we do these on our calculator, you're going to see a symbol that looks like this, which is called X bar. If you take stats, you will also sometimes talk about mean as the letter mu, or the Greek letter that looks like that. All right, and the mean is simply the average. So that's a great way to summarize data or talk about the middle of the data, as long as you don't have outliers. If you have really high or really low values that don't belong with the rest, they can really stretch that average away from the rest of the data points. So we would just take the sum and divide by the number of items. You guys know how to find an average. All right, the median is the middle number in a list after you've put them in order. And if there happen to be an even number of items, you average the two middle terms. The mode is the most often occurring number. If you have a list like 1, 2, 3, 4, there's no mode. If your list is 2, 2, 3, 3, 4, then the mode are both 2 and 3 because they both occur the same number of times as far as most often. If you had a list like 2, 2, 3, 3, 4, 4, 4, then 4 is the mode. Okay? So there can be none or multiple. All right, so I have some data here. Oh, I didn't erase this. What do you know? Well, you know what? I'm just going to go through this quickly because you guys are really good at this. I just put the numbers in order. So there was a 35, a 46. I crossed those off. There was two 51s. I crossed those off. Then there was a 53. There were two 58s here. This is supposed to say 58. Then there was a 59 and 60. So the data points are really pretty well close together. So a good measure of the center would be the mean. I added them up and divided and got 52.3. All right, there were 1, 2, 3, 4, 5, 6, 7, 8, 9 data points, thus the 9 here. And so there's 4 on this side and 4 on this side and the one in the middle here. Make that into an arrow, was the median, and the mode was 51 and 58 because those occurred most often. If we have a longer list of data, we can also type them in our calculator. Now I will tell you that the calculator does not find the mode, but it will help you by putting them in order if you want. Now, I'm going to skip to the notes down to the section that talks about how to put them in the calculator. It says the calculator steps are stat enter to enter things into a list, which we did the first week of school when we did linear regression. So I hope that looks familiar. After you put the points in, we're going to go stat, right arrow over to calculate, and we're going to choose the top one here, which is one variable stats, and we're going to scroll down there. All right, and we're going to talk about what all those things mean in just a second, but I'm going to start by doing this list of data points real quick. I am going to put in, so I go stat, enter, and then I have my list like this, and I'm going to type those data points in, 21, enter, 10, 27, 24, 15, whoops, I messed up already. 7, 19, 24, 31, 15, 11, and 24. Let's see if I have them right. Put this over here so I can check. No, the first one's wrong, or maybe the first two aren't showing. 27, 24, 15, 7, 19, 24, 31, 15, 11, 24. So if I go back and scroll up to the top, do I have 21 and 10? I do. Okay. So the second thing you do is you go to this vars again, but no. Sorry. You go to stat, okay? But you arrow to the right. Stat, arrow to the right to calculate. You want to calculate something. What we want to calculate is using list, or using the one variable stats, because we only have one list of numbers, okay? If you wanted to compare lists in two numbers, then two numbers in lists, two separate lists, then you would have a whole nother can of worms, okay? What is happening here? All right, I'm going to quit. I think I forgot to quit out of that before I did the one variable stats. So I have to quit, then stat, right arrow, enter. And you want to make sure you don't put a frequency list in. Frequency lists are very helpful, but this year, we're not going to take time to mess with a frequency list. So we just put all of our data in one, and we're going to leave the frequency list blank and go down and hit calculate. Now, we need to understand what all of these things mean eventually, okay? But for right now, the two you need for this question is that the mean is 19, and then median is not listed here, but do you see there's this little arrow? That means you can scroll down, and median is 20. So we have 19 and 20. Now, the other thing you can do, and this is a little complicated, but if you had a lot of numbers and you had to find the mode often, it would be helpful, is you can go to your list here, and so it's just stat, and you can choose to sort the list. So I'm going to just sort in ascending order or descending, it doesn't matter, but I'm going to choose choice 2, and then I'm going to put second L1, because that's the name of the list where I put things. So I'm going to ask it to sort list 1. It'll say done, but now when I go back and do stat enter, the numbers are all in order. So I can see that there's 2 15s and 3 24s. So the mode is going to be 24 because there were 3 of those. I underlined them and figured that out ahead of time. Okay, so the mean was 19, the median was 20, and the mode was 24. All right. The variance has a lovely formula over here. It's if you take each item and subtract from the mean, so how far away is each item from the mean, and then you were to square those and add them all up and basically average them, okay? We're just going to say it's the standard deviation squared. Or the definition in terms of concept. Let's see, what did I write on here? Sorry. Variance is the average distance to the value of the mean. Yeah, I'm not going to worry about it. Okay, just put standard deviation squared. So the square root of the variance is then the standard deviation, but we're just going to do them on our calculator, okay? Standard deviation is one of the most useful things for describing how data is spread out. And we are going to work with that number tomorrow. But today, I'm just going to show you how to calculate it on your calculator. So a lower standard deviation or smaller amount of variation means that the values or the data points are closer together. And a higher standard deviation indicates that the data points or the values are more spread apart. Okay, so closer together, smaller standard deviation number, further apart, higher standard deviation number. All right. So we're going to type these in, and the calculator is going to give us the standard deviation. The notes here say to use this symbol, which is the population standard deviation. The calculator gives us two kinds. I guess I'm going to, here, let's go to this screen. You have this in your notes. It's underneath these two questions. But let's talk about what these all mean on the calculator, and then we'll go back and do some practice. This X bar, you just call it X bar, is the mean. This is the sum of all of the items. This is the sum of their squares. So you'd square each separate item and then add that up. This is the sample standard deviation. And if I wanted you to use that one, I would put S of X. But if you see this little symbol, that's what they're going to use. It's actually called the population standard deviation. And I think that's what they ask for even in Delta Math, but if they ask for S, you just use this one. It's very clear. There's not a question about it, okay? This is the number of items that you have entered. So you're finding the mean of 7 numbers. Then these down here are called the 5-number summary. And they are used to make a box plot. So you have the minimum value. This is the first quartile or the 25th percentile. It's called the first quartile. This one is median. You know that one, which is actually the 50th percentile. 50% of the data is above 50% below the median. Okay, Q3 is the 75th percentile or the third quartile. And then the max. And if you want the range, which it asks for sometimes in Delta Math, if they gave you this picture and they said find the range, you would do the max minus the min. And they could ask in Delta Math for you to find the interquartile range, which is Q3 minus Q1. So for this data, you do 253 minus 199, and I think that's 54, is the interquartile range, okay? Let me go back up and talk a little bit more about variance and standard deviation, and then we'll do box plots and be done. If we put these numbers in the calculator, 3, 4, 7, 8, 11, so I'm going to go up onto the title, if you remember, all the way up to the top. Just kidding. Carefully. Then I do clear enter, not delete. Okay? If If you delete, you're going to have a problem. If you were to forget and delete that list, then you have to do second delete to insert, and then second one to rename it and enter to rename it list 1. All right, then when you put the data points in, we had 3, 4, 7, 8, 11, 12. 3, 4, 7, 8, 11, whoops. 12, which I messed up also. Then what? Another 12, 15, 19. All right. It says I am looking for a 10th, so that means there's 9. Seems like I have them all in and incorrectly. So then I go stat, arrow to the right, enter, and I can just hit enter a couple more times because I don't have a frequency list. And then here the mean is 10.11, the total, blah, blah, blah. But what it asks me to write down is the standard deviation, okay? These data points have a standard deviation of 4.86. Now, that means they're spread out, okay, a certain amount. So if you found the middle, and then we could talk about this distribution tomorrow, but if you had another set of numbers with a higher standard deviation, it would mean they were more spread out. The variance, guys, all you need to do to find variance is take that number and square it, okay? We're not doing anything complicated. We're not going to do variance by hand. I don't know what they make you do if you take the AP Stats test. Some of this you might have to do with just a regular calculator. I don't know. And you don't need that many places. I just wrote that, okay? So there's the variance, and the square root is this standard deviation that we found on the calculator. All right, I guess I can do this other one real quick. It's stat, enter to go to the list, up arrow, clear, enter to clear them out. Then you type the data points in, 52, I think there was a 47 next, 60, 55, 58. $53, 59, and 63. 53, 59, I already messed that up. 63, I think I remembered them right. And then you don't actually, I think you don't have to quit out of this. I can't remember. I'm going to quit out of it. And then it's stat, right arrow, enter, and we'll put that on here just to remind us where we got those numbers again. So this one, let's see, is 4.8. 1 if we went one more place. And then this would be that squared. So that's 23.1. So these two sets of numbers have a very close standard deviation to each other. That means they're separated in similar fashion, okay? You'd have to look at the means to compare the data points more clearly. All right, last thing, tomorrow we're going to talk all more about that stuff, but last thing I want to talk about is box and whisker real quick. The box and whisker plot are the ones that look like this, and the bottom line is that 25% of the data points are represented in this whisker, 25 in this whisker, 25 in the left half of the box, 25 in the right half of the box. You put them, draw them by plotting the minimum and the maximum, and then the box goes from Q1 to Q3 with the median, the line in the middle. Okay? If you are to subtract Q3 minus Q1, you would get the interquartile range. The idea is that if you were to have one that looked like this, okay, this is still 25% of the data, and this whisker still represents 25% of the data. The difference is that this whisker's data is much closer together, okay? This half of the box is 25% of the data, and this half of the box is 25% of the data. So the middle half of these data points, this upper 50%, is much closer. Like, you know, if it was numbers between 1 and 10 that we were representing, there might be 8, 8, 9, and 10, whereas down here we had, you know, 1, 2, 3, 4, 5, 6. So they were more spread out. Okay, so real quick, this box and whisker plot that is shown here already, which is not related to this. So we have 25% of the data here, 25% here, 25% here, 25% here. So the upper half of the data is from, let's see, 40, 42, 46, 48. Nope, that's 50. Oh, that's 45. Okay, they're counting by 5. Sorry. So is between 45 and 80. That's how you would read that. And the lower 50% is between 5 and 45. And so these data points are more spread out, etc. And then I'm going to show you how to do this on the calculator. You enter these data points, and then you scroll down and find the 5-number summary. So after you put them in, 30, 38, 40, 44, 50, 55, 60, 66, 66, 80, 90, and 98. Then you go stats, right arrow, enter, 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 and you will need to scroll down when you get to that spot, because what we want is the 5-number summary, which is the min of 30, the median, a Q1 of 42, 57.5 was the median, 73 was the third quartile, and the maximum was 98. The range would be max minus min, so 98 minus 30 or 68 if it asked for it. The interquartile range would be 73 minus 42 or 31. Did I subtract that right? If it asked for that in Delta Math. Okay, so the last thing, you have to do a little project this week, and that project has you maybe draw a box and whisker plot if that's the way you want to display your data. And for this one, you would say the min was at 30, and then Q1 was at 42, which would be just past 40. And then median was 57.5, which would be close to 60 up here. Should be a little further to the right. And the Q3 is at 73, so this is 70, 75. It's almost to 75 up here. And then the max is 98, which is almost 100. Okay, so that's how you draw one once you have the data. It is possible to do it on your calculator. I'll show you real quick. It's second y equals to turn a stat plot on, which once you turn it on, you're going to want to turn it off later, or your other things aren't going to graph. And then if you go over here, there are these little things that I like to say look like robot heads or something. They're these funny little box and whisker plots. And then remember, we do a zoom stat when we have something like that. So that's what it would look like on the calculator. And if you trace, it will tell you those points. Okay, so real quick, one more time. It was second y equals, turn the plot on, and pick the either fourth or fifth one over here. Okay, and then it's zoom 9. Now, if you have, zoom 9. If you happen to have something in y equals, it might show up on your graph, so you could clear that out first. But when you are done, make sure you go to y equals and go up and turn that plot off, or you go back to second y equals and turn this off. Otherwise, it will mess up when you graph other things. All right.